Okay, this is my idea for a type of laser that's very similar to a free electron laser. I call this the oapl laser for open air proton laser. Now the idea behind this is that you do not need a vacuum chamber like in a typical free electron laser or most other lasers. So bear with me and I'll explain it. It starts with a tank of hydrogen, H1 to be specific. You have a regulator here, and when you first start this up, you open up, well, not a regulator, a valve. You open up the valve, it floods the system, pushing all the air out, hopefully all the oxygen too. That's an important part. Once all the air is flushed out and you have just hydrogen coming out the end, that's when the rest of the system turns on. So the hydrogen, as it's flowing into this section I call the separator, the electron is at its normal distance from the proton. You have a maze of tubes or channels that the hydrogen flows through in this section here. This section is rapidly heated by either induction heaters or microwaves, whatever you prefer, and the entire frame of the separator is exposed to a high voltage field. So as the hydrogen enters there and it's being heated up or exposed to heat, the electron is going to get further away, weakening its bond to the proton. If it gets far enough away, the electron will be ripped from orbit and pulled to the separator. A side view shows that the channels have to be very, very thin in order to get the rapid heating that you need, and here it shows the induction heaters. The idea is that on the output you want just a stream of protons. And then they enter this section here, which I call the compressor. It is also a high voltage field, but it is of the same potential as the protons, and what it does is it pulses in such a way to condense a stream of protons into a packet that is of the same width as the wavelength for the beam that you want to create. So the protons coming out of here are in packets, and then they enter this RF drive. It's a type of particle accelerator that uses RF to accelerate these packets into the undulator. Keep in mind, all of this is exposed to air all the way back to the valve. Once it enters the undulator, unlike a typical undulator, this one is not in a vacuum. And another thing is this entire undulator has a high voltage field with the same potential as the protons. You notice these circles in the middle. Those are solid pieces of probably aluminum that are charged to the same high voltage potential. This has a couple of uses actually. If you look at the side view of this undulator with the magnets and the various poles, you'll notice those same blue circles here. They keep the magnets basically apart from each other. You want this to be fairly thin, so the force between those magnets is going to be rather extreme. The other advantage of having these be high voltage with the rest of the frame is that it can more accurately shape the beam as it's moving through here, because the packets of protons do not want to touch the outside, and they do not want to go anywhere near those circles, basically. So as they're traveling through the undulator, they're of course forming the beam along the outside. And then they enter this section here, and this is one of the areas that's significantly different from a free electron laser in the fact that the particles don't get recycled or disposed of. Instead, use a magnet to focus that beam of protons, the packets, inside the beam that you created, the laser that you created. Alright, so they're entering another section. This is a final accelerator where it takes those already fast-moving packets of protons and it accelerates them even further and sends them along the beam path. Now this has a number of advantages. For starters, the varying energy states of both the protons moving through air and the fact that they will be robbing energy from the beam as they lose energy means that they will help keep that plasma hot along the entire beam path. When the protons hit the target, whatever that is, the protons are basically highly acidic in nature when they're in their free state. So if there's something reflective and they impact it, you're going to have a number of things that happen. For one, you're going to have an EMP from basically these protons with a massive magnetic moment traveling at high speeds. You're going to have it destroy whatever reflective surface it hits, and then you're going to have your laser, which would be a lot higher energy in a lot shorter space than a free electron laser because of the increased magnetic moment of the protons. And all of this is made possible because it's all exposed to air, but it pushes the air out during the whole process and replaces it with the particles that are supposed to be in there, which are your protons. And that is the open air proton laser.